Dairy tankers operate in some really challenging environments. Winding country roads, narrow driveways and tight confines around pickup sites. We see in our NTI claims data that in addition to high-speed rollover incidents, we also see a number of low-speed incidents. Clipping other vehicles at intersections, hitting buildings and infrastructure, or dropping tyres into unseen holes and culverts while turning in and out of properties. A key factor in how the vehicle behaves in these tight confines is the swept path or turning performance of the combinations. So we've made a video that looks at the difference between some of the highest performing and some of the lesser performing combinations used in dairy pickup.
Vehicle suitability and access to various routes is often dependent on low-speed swept path. Low-speed swept path is the technical term given to the amount a trailer cuts in closer to the apex of the corner than the prime mover does. The larger the swept path, the more road space a truck needs to negotiate the corner. To demonstrate this, we've engaged well-known industry expert Peter Harbridge to create a low-speed swept path demonstration at McColl's Yard in Tongala in Victoria. We are being assisted by a number of highly skilled drivers in combinations that the dairy industry use in their daily operations.
Today we're setting up and marking out a full-size Level 1 PBS template, which is typically what a standard 19-metre 6-axle semi-trailer combination is required to be capable of negotiating. The swept path is ultimately determined by the length and the spacing of the components of the vehicle between the pivot points and the articulation points. We have some PBS combinations with steerable axles today, as well as conventional fixed axles, so it'll be interesting to see how they go in comparison to each other. So today we've marked out at a 12.5 metre radius an outside arch for the or curve for the trucks to follow. We've got some intermediate marks to signify, for easy reference, the swept path as each truck goes around the curve. Indicated by the yellow lines at 4, 5 and 6 metres. We have a pink mark at 7.4 metre swept path to indicate a Level 1 PBS swept path. This pink mark is marked at 8.7 metres swept path to indicate a Level 2 swept path. And just for comparison today, we've got also marked out Level 3.
Yeah, so today we have 8 different combinations here that we're going to put through their paces. And in simple terms, we're looking at the difference between the path of the outside steer tyre in relation to the inside rear trailer tyre.
Hi, my name's Jeff. This is a 6-axle semi-combination consisting of a cab over 500 Volvo prime mover with a Tyman tri-axle trailer. Overall length is 14 metres and it can carry 28,000 litres in the tank.
G'day, I'm Bruce. Today I'm driving a 19 metre 7-axle B double. That's a Byford tanker. I'm pulling it with a Volvo 540. Carries 34,500 litres.
Hi, I'm John. This is a 9-axle B double 25 metre Byford combination. On the front, FH16 Volvo. Overall length is approximately 25 metres and it holds about 41,000 litres of milk.
I'm Ash. This is a 9-axle 26 metre A double combination. Byford trailers with steer axles. 46,500 litres, being pulled by an FM 540 Volvo.
So looking now at the split screen, we get a really fantastic visual representation of the difference in the turning performance of these 4 combinations. The thing to pay attention to here is the Level 1 PBS line. Of the 3 pink lines at the inside of the corner, it's the one closest to our combinations. So looking now to the top left, we see Jeff's short 14 metre semi-trailer. This is really our best case, and as we'd expect, it significantly exceeds the turning performance required for Level 1 PBS certification with a swept path width of 5 metres. Looking now to the top right, we see Bruce's 19 metre pocket B double. This combination gets you the same road access as a standard 19 metre semi-trailer, but with additional mass because of how the axle groups are laid out. And it also significantly exceeds the turning requirements of Level 1 PBS, with a swept path width of 6 metres against a PBS Level 1 requirement of 7.4. Now in the bottom left, we've got John's 25 metre B double combination. This is a 9-axle B double. Now, it's pretty close to being the design vehicle for level 2 PBS. However, if we watch its turning performance here, we see it only just crosses that level 1 PBS line with a swept path width of 7.6 metres, so doing really well there. But it's clear to see that the standout of these four is Ash's 26 metre tandem A double set. Each of those tandem axle groups has a steerable axle at the rear, and thanks to the extra articulation points of the A double and those steerable axles, it has a fantastic swept path performance of 6.05 metres, nearly the same as that 19 metre B double, but with an additional 12,000 litres of payload capacity. A really fantastic performer, and also thanks to those steerable axles, it should tear up the road less when turning around on tight sites.
Okay, so we have here our level 1 swept path line, which indicates a swept path between the outer curve and here of 7.4 metres, level 1 being the limit for PBS level 1. As expected, our 14 metre semi did exceptionally well with a swept path of only 5 metres between the inner edge of the inner tyre to the outer edge of the curve. It did very well. We then tried a few different B doubles. The 19 metre B double indicated by this blue line here had a swept path of 6 metres. So again, quite well. It's a 19 metre 7 axle B double. The 26 metre tri B double was just outside the level 1 swept path with a swept path of 7.6 metres. This next green line was, again, a 26 metre A double, but with tandem axle groups on each of the trailers, still steerable in the rear of each of the trailers, each of the axle groups. It had a swept path of 6.05 metres, so marginally worse than the tri trailer set, but still well within the limit of the level 1 swept path.
When sitting beside a driver during training session, it can be difficult to set the stage in a driver's mind on how a vehicle will react when approaching, entering and leaving a corner. Filming this demonstration will be invaluable to our drivers and trainers. It will provide us a visual perspective to reactions and assist us all to change driver habits, negotiate corners better to protect themselves, their equipment, customer assets and the environment they work in.